All right, we're doing this question, and this is asking for what is the reaction force at point A for simple support beam. So over here, it's basically a small cut, but over here there's something like this. Actually, let's just draw it on top of the. I mean, we can, but in the real exam we're gonna have to draw it out again. So this is how we have it. Now we have this whole thing, which because it is a triangle, we can do a centroid and say that this is basically whatever W, right? This W with integrated, but whatever this area is, which is W O, actually, what is this? L divided by 2 because it's L, is that, and we can say force over here is W O L divided by 6 B over here, like this. Now, note over here, we're looking for a reaction force. AX equals 0 because there's no reaction force possible with this one. In this case, we can do a momentum, actually. Sum of all the moment over here must equal 0. So in this case, we can say, actually, no, we can't because we're looking at, actually, we need B, right? Yeah, we need B. So we chose A over here for that. And then, so this over here linked, I didn't say it, is L over 3 because of how the what was it called again? Um, how centroids work. L divided 3 multiplied by WOL divided by 2, right? The length over here, plus WOL divided by 6 squared because of the L over here, equals to plus B over L equals 0. So in that case, we could just write back over here that B equals at least 1 over L parentheses, we're gonna have a negative over here, and this is gonna be WOL squared divided by 2 plus WOL squared divided by 6. So in that case, it is equal to saying negative, and I chose this direction, so it's actually this direction, but negative 1 divided by L, so it's gonna be, well, we'll figure that out later, but that is B. So we can sum up all the y's now. Actually, we should probably simplify this as b, and then we can do 3 over 6, and 1 over 6 is 4 over 6. And then we can say this is equal to WO, so it is 4 over 6 WO L squared divided by 6. I think I did this wrong. Yeah, this is just it. This is all I need to write. Erase that. So that is 2 divided by 3 WOL. Sorry, I didn't erase that. Why is it not racing? Okay, there we go. All right. Am I correct about that? We'll see. With that moment, we'll see. We could, oh wait, what am I doing? We could have done a moment on B and got it done with because we already know AX. Why am I doing all this fancy stuff when I could do that? Sorry, let me just erase this whole thing because yeah, we could do the hard way, but now I know my brain says there's an easier way, but we'll double check on B later. But we could have just done a moment on B with summation equals 0. With that said, the moment on B, this is L, right? So we can have done moment on B, so it is WOL squared divided by 6. Um, and that's negative direction. What am I doing? Sorry. Okay, anyways, over here we have 1 divided by 3, but this is also 2 divided by 3, L. So it is basically saying, and then this is the positive direction, so plus WO L squared because of the L, uh, divided by 2, parentheses 1 plus 2 divided by 3, right? Yeah, L plus 2 divided by 3, yes. And then plus 2L multiplied by AY, right? Equals 0. So in this case, we have this formula over here, and we can add, subtract, we can do a lot of stuff to make this easier. But I think the best way is to grab a calculator. Oh, by the way, we can, now that we have this formula, we can just start erasing the extra L's in the place to make it into that form. Yes, basically. And then we can do, we can just do we can just plug it to the calculator. So WL, negative 1 divided by 6, plus 1 divided by 2, 1 plus 2 divided by 3, plus 2AY equals 0. So let me just parenthesize this and put that into the calculator. Negative 1 divided by 6, plus division 1 divided by 2. 1 plus division 2 divided by 3, parentheses, and then there'll be negative version after I move it to the other side. Huh, what? Is it 2? Negative 1 divided by 6 plus 1 half plus 2 divided by 6. So 3 divided by 6. Wow, that is a coincidence and a half. Oh, wait, wait, wait. Sorry, clear parentheses, this multiplied by -1 is -2 divided by 3. So it is AY equal WOL 2 divided by 3 negative. The negative drops, no wait, the negative drops out. Did I make a mistake here? I think I forgot something. Uh, so -1 divided by 6. Okay, and then did I do something? Oh, wait. Oh, this is negative. Okay, so this is negative, negative. Okay. Which equals -1. So this gives me -1. So if it's +1, this gives me 2 then. And this is A WOL divided by 2, and that is A. Over here, determine the reaction point as C. So this reaction point is all we need. So there's a few things over here, 15 over 15. So if I were doing a moment, this would be 0. And we need to actually know if it's up or down. Okay, so we know this is going to be right in the middle at 0.5. So best bet is to do a moment over here. I can see that now. I can do a force analysis over here, but I think AX has to be 0 again because of how, look at this cancels out this over here, but there's no other force in the sideways direction. With that said, we have this force over here, which is AY. AY is actually still needed, and we can do a moment on this over here to figure everything out. So if I were to do a moment on this, oh wait, well, if I were to do a line of action like this and line of action like this, they do cancel each other out in terms of this. So I don't really need to worry about these two yet. Never have to, never will. Or maybe I don't. Maybe I will later. Anyways, this is 10,000 newtons per meter, which means you just have to multiply by 1 for this case, but this is here. So we'll do a summation of a moment at A equals 0. So we'll do a half, parentheses, 1 10,000, just because of how it's just 1, and 1 multiplied 10,000 is not because of anything else. And it'll be wait, is this positive or negative? I keep on not checking it. It's negative. And this is over here is positive 2,000 newtons. And this newtons is multiplied by this amount, 1 plus 0.6 plus 0.8 plus 0.6, which is 3. So this is 3 in the positive direction, plus CY equals 0. CY equal, well, that's 5,000. Let me just put in the calculator for all of you to see. 5,000 minus 2,000 multiplied by 2. That seems ridiculous. Yeah, that sounds ridiculous in my head too. So obviously I made some kind of glorious error on this one, but I think I'm doing the right process. Or maybe I'm doing it wrong. Oh no, this actually does matter. That's the whole point. I'm so stupid. Thank you, brain. Sorry, it's late at night. I am not doing this well. So it's like 1.6, right? And it is the negative direction, so erase this to negative, and I'll multiply by 2 because of 2 of them. And with 2 of them, it should be good. Oh, wait, and I'm also flumming here. It's 0.4 because you're going to the upstream. You get what I mean. Now we can do what we want. Plus 1500, 4 multiplied by 2. Okay, I am fumbling the numbers. Oh, wait, there's something I am forgetting. CY has a number over here, which is 2.4. So I need to divide everything by 2.4. Yeah. Which is CY equal 82.3.33. And what did I choose? The positive direction. So it must be plus that. It must be C. It must be C. Okay, with that said, we move on to the next question, which is adding all those up. Over here, we have a bunch of them, but wait, why is there different? I mean, isn't it just this because of the same distance? I mean, we'll check. Yeah, 35 and then 25. Yeah, it's I. So it's A. I don't know what the point of that question was. That was this is a missed opportunity question. We're going to do this one where we're doing a resolve a force, a 300 Newton force right here. And we're trying to get the other component away. And the way to do this is basically just the same exact playbook. Total summation of Fx start. We can this one, don't make it 0. That's trick. So with this one, we do 300 cosine 25. Okay, now that determines something, but we really don't know where x and y is. Right now, it could be x and y like this, but it's basically x and y. But here's how you get it. This has to equal F force in here, and if you were to get F force in here, this big. So it's Fp plus Fq cosine 25 plus 75, 45, which is 75. Huh, okay. I think we need a summation of Fy, which is, again, this, but sine. So 300 sine 25 equals FQ only. The other one doesn't have any play. And then you see that it is the sine version, so sine 45. Huh, we can get Q, is what I'm hearing. So FQ equal 300 sine 25 divided by sine 45. If you grab your calculator, you can figure this out, and then plug this back into Q to figure the rest out. But seeing that the Q has no other version, it probably is fine to just say 300 sine 25 parentheses divided by sine 75, which is 131. Did I make a mistake? Oh yeah, 45 plus 25 equals 70, not that. All right, what I get the right answer this time? This is 134.5.9, 134.99, something like that. But it is basically C at this point, and none of the other answers make sense, so we're gonna go with C. If you want to double check it, you can plug it back into here and figure out FB, because FP, well, to get FP, basically you have this, right? Which is equal to 300 cosine 25 minus FQ cosine 75. So 300 cosine 25 minus Q, which is 134, cosine 75, which equals 237. Did I do, not 75. I keep on making mistake. 70, sorry. 226. I get FP equal 226 newtons. Therefore, C is correct. Which type is a load not resisted by a pin joint? A moment. It is A. No questions about it. A. If you don't know why, uh, well, how do you explain it? So imagine a pin joint. It has a pin like this, and it can only have a force normal to the pin. Like if I were to do something like this, you can see the surface is touching, but there's nothing stopping it from rotating like crazy, basically, is what I'm saying. There's no threads. Three force act like a hook to determine the magnitude of the resultant force, neglect hook bend. Okay. So there's a hook and there's a magnitude force. Okay. So in these type of questions, which one do you want? Resultant or demand? Okay. Okay, so we need to do a summation of fx first, which is going to be 1000 cosine 30 minus 15,000 cosine 20 minus 750 cosine 15. And that equals negative 1267 newtons. Is that correct? Probably, seeing how it's arranged. Summation of fx equals 1000 sine 30 plus 1500 sine of 20 minus 750 sine of 15 equals 818. Okay, does this even make sense? This implies that it's going to be D, basically. And I guess we just got to accept that. Yeah, yeah, it's D, I guess. I'm double checking my math. If you're asking why they have to do the final step, it's because this is already bigger than C. Therefore, the only answer with the addition of 818 was D. So, yeah. Okay, So for this question, we're given a bent beam is acting upon by a moment as several concentration force as shown. Find the unknown force F and the distance x. So the first thing we have to do is summation of Fy equals 0, which will show you because 60 is a negative, and then plus 10 plus 20 plus 10 plus F. So this over here equals 0. And then you can say F equal whatever this is minus. So it is 60 minus 10 minus 20 minus 10, which equals 20. So these two are deleted automatically. It's 20 newtons. With that 20 newtons given, we can figure out how to get the moment, the x, by looking at this form over here. We can look at the 10. Let's just redraw the thing where we need it, because we're just going to do a moment on B or A, doesn't really matter. We're going to do a moment that is m equal 20 newtons per minute. We're going to do C over here is 0.2. We're going to do X over here, which unknown. And then we have 10 newtons over here, and we have 0.2. And then here is E, so this is 20 newtons. So we can do summation of m equal 0 at whatever A or B, doesn't matter. So then again, we need to look at this, and we have to do minus 20 first, plus 0.2, and the C is 20. I don't know why you call it C. 20 newtons. And then it's going to be plus 0.2 plus X, 10, plus 0.4 plus X, 20. With that said, I can make this equal to 0. And we can say 0 equal negative 20 plus 0.2, 20 plus 0.2, 10 plus x, 10 plus 0.4, 10, 20, sorry, plus 20x. So this turns into 30x. So we can do 30x. And now we can plug the rest into a calculator, or we can do it ourselves. But minus 20 plus 0.2, 20 plus 0.2, 10, and then plus 0.4, 20 plus this. So either way, it's a risky operation because there's so many things, and you can definitely make a mistake on your calculator. Very easy to make a mistake on your calculator. Anyways, 0.4. By the way, your calculator has a lag, so if you do it too fast, it actually doesn't calculate everything. So you want to actually do it a little bit slow. I got minus 6. So that would mean it is, if I go the other way, 6 divided by 30 equal x. Okay, clear. 6 divided by 30. This one you could probably do it without any, without the calculator, but I like to just do it with my calculator. It is about 0.2, so that means it's C, and I hope I got the answer correct. We move on. Anyway, 4 bolts not shown connect support A to the ground. Determine the design load for each of the 4 bolts. Okay, where are the bolts? What? I don't understand what the question is asking for. There's no bolts. There's nothing missing, I don't think. Let's just reread the question. Support A to the ground. Oh, 4 bolts. Okay, not shown. Okay, yeah, that makes sense. Okay. Determine the design load for each of the 4 bolts. So I have to divide that by 4 is what they're saying. Yeah. So I think you should be doing this. Is this? There's a 30,000 load Newton here. There's a 4 over here. I don't think that really matters, but there's a force over here this way, and there's a force over here this way and that way. Well, to make it clearer, we could just draw it like this. Okay, so with that said, we know the distance between this is 6, and this over here is 4 meters. 4 meters. Yep. So what we can say over here, oh, this is 2 or 4 over here. Oh, this is a somewhat interesting triangle. Okay, we can actually figure out everything here, right? There's 2 unknown. This is going to be by. There's ax, ax. Oh, wait. Ax equals 0 because of summation of fx equals 0. Therefore, we used one of the equations up. So we only have 2 more equations, the y direction, which really cannot give me anything. And we have the moment direction, which can give you something. So I'm going to do a moment on A. So we're going to do summation of moment. Actually, no. We should be doing a moment on B, because with the moment on B, we get AY. And AY is really what we're looking for. We're not looking for BY, because it said the 4 bolts. So in this case, I would actually want to do a moment on B equals 0. And here we have 30,000 newtons. We do that, multiplied by 4. And is it a negative or positive direction? It is definitely a negative direction. From here, we can do AY. We can do positive. Wait, it's negative direction, negative direction. What? AY is a negative direction too. That means I got the direction wrong. Oh well. And then we could do 6. Oh, I just got it. These lengths are hints to what makes the question easier sometimes. I see. Beautiful way of thinking about it. I didn't really notice that until today. So 6, you go to the positive and then negative again. So it is in, well, if it's negative, it means it's this way, which means if we cut it is intention. 3, that was it because we're looking at internal really for tension. On division, negative 30,000, 3 6s, right? Multiply by 4, divide by 6. I get 20. Okay, so um, that doesn't sound right. Did I make a mistake? I get 20,000. Um, yeah, I think I did it right. It's 20,000 and it's intention. Um, oh, for each divide by 4. So it is B. So problem 8 through 10 refers to the following frame. The 700 newtons are applied to B. Okay, beautiful. What is the x component of a 300 newtons force at point D? Okay. Um, is it why is this a question? This doesn't feel like a question. So all you have to do is just get this portion, right? So it's 300 cosine theta, right? Equal f dx, right? So I'm confused what you're trying to do. Oh, sorry. Sine. What's the point of this question? Sorry. Maybe. Oh yeah, probably it's like a setup question. So therefore, the first part is I don't know. So dx equal 300 sine theta, right? And sine can be determined by looking at this and saying, and this is a negative direction. So negative 300 parentheses. The sine is. Oh wait. I need to figure out 12 square plus 25 square. What does that equal? So it is 5 square plus 12 square equals 13. So this is 13. So the bottom is 13 divided by 5, right? Equal dx. So I think that's it. 300 multiplied by 5 divided by 13. 115. So it's A. Um, I'm not sure what the point of that question really was, but thank you. Okay, here's what we have. Problem 9. A single force member not shown is applied to point B. Okay, point B. In the y direction. Okay. In line with point A and D. What? Okay, A and D. Okay. It looks like it's a simple making sure everything is okay question, your knowledge question. Um, Basically, I think what? A single force not shown is applied at point at B in the y direction, in line with point A and D. Okay. Okay, not big a deal. Okay, I'm pretty sure it's just a summation question. Um, so it's still worded weirdly, but I think it's just Fy equal 0. So you just have to look at Fb, which is going to be the plus direction for now. And then it's going to be plus Fa y plus Fdy plus Fcy. And in this case, equals 0. So we could do FB is obvious, and then plus FA, which is 4, 5 triangle. So it's going to be 200. And it's going to be a sine of theta. We'll figure out that later. Plus FDY, which we figured out last time. 300 multiplied by sine. Wait, is it sine? What did we do last time? It was, what we get is A. X component. No, this is X, that's the X component. We need a Y component. So over here, if this is theta, we will do a cosine. Yeah. Actually, it really depends on which way you do it, really. But I'm gonna do cosine because I'm a little bit of a weird one. This is cosine 2, cosine 1, sine 1, cosine 1, and then plus f, this is gonna be negative 150. So with the negative 150, this equals 0. So it's gonna be FB plus 200. Sine is the adjacent, so it's gonna be 35 plus 300, and it's gonna be cosine 2, so it's gonna be 13 on the bottom, right? 13, and it's gonna be what? 12 minus 150. FB, therefore, as we decided to do it, equals this whole thing minus. Yeah, we're just going to put in the calculator because I'm lazy and don't want to write the whole thing out. Minus 150 summation. Okay, I get a number. I definitely get a number. I get negative 246.9. I'm assuming it has to be C. Um, I don't like how it's not exact, but sometimes these questions are not exact. And you have to accept it. They round it up to the second digit, and it's just what it is. It's not really your fault. They just do it like that. Okay, next question is this one. Okay, this requires a little bit of thinking. So over here, it says that everything is deleted and is replaced with a vertical force F point F. So what is deleted is the question. It says if the disputed load and vertical load. So it means this and this is deleted with a force of 1700 newtons. I'm assuming that means what happened is basically upwards, right? He said upwards? For the upward force of 1700 newtons at point F. Okay, and also remember this is still a static question, which I don't like how they phrased it, but static question, y must equal 0. Now, this implies E must still be the same reaction force, so we could actually get rid of that in the moment difference. What that means is that we don't really give a crap about it. Weird to say, but we don't really give a crap about what the moment difference is. But we do actually care about this. I mean, really, the reaction at point A is unknown, but it is not relevant, basically, since the reaction is unchanged. And it's not necessary. We can just get rid of it, basically. And we could assume many things, but we should probably do a moment on B. Just to give it the two bad forces. So what we're going to do is first do, because actually speaking, we're looking at the difference between these two. So we're not actually looking for it to be 0. Now that's the trick of the question. We're trying to make it 0, but if you look at the difference between these two, we can figure out the truth. Okay? So we're going to do, usually we do clockwise as positive. We denote it by this, by professors do that. So we're going to do 400 multiplied by 2. And then the length of that will be 2 divided by 2, so it's going to be 1. And it's a negative or positive. For us, because it's this way, it is positive. Okay? And the next thing we'll do is get a moment on 900. I honestly think this question is a little bit out there. I don't think this is actually going to be the FE exam question because, oh my God, if it is, well, it's a weird question indeed. It's going to be 3 plus 2.5, so 3. I'm just going to write this as like, just do it like this because I'm lazy. By the way, if this that is the moment on 3, 1.5, and 1 plus 1, that's a distance, and there's 900. So that creates a moment. Let me check over here. That creates a moment positive for our, wait. Let me erase this so I can actually read this. Yes, it is a negative. Sorry, negative. Right hand rule, please. Always make sure to do that. Next, we have to do a force on the 7,000. So it's going to be plus 17, right? 17,000 multiplied by 3 plus 1.5. And that is all. Okay? Am I forgetting something? No. And you might be asking, hey, John Lely, there is 15,000 over here, and there's a moment over here. Why are we excluding those things? You might be asking, because they're unchanging. They're not the focus of our change. And we need to look at the things that are changing. And the things that are changing, they said, was this portion and the 900. So in our analysis, this thing does not exist because same in theory. In reality, other material properties and things it doesn't work like that. But anyways, also we could have made the same argument on B. Fun fact. But we could have, doesn't mean we should have, because there is a little difference here, but you'll see that later. Because in this whole thing, the whole balance B must be the only way for it to actually change. You'll see, you might not get what I'm saying, but it is not the same because the problem statement didn't specify. It said E has to be the same, but that doesn't indicate B has to be the same. Read the question. It does not say that. It says would be necessary to keep the reaction at point E the same. So this is like a weird bad question because in reality, I don't think this is going to really happen. This question I don't think is actually realistic on how it's supposed to be. But in reality, that's what the problem statement has given you, so you have to follow that. But in reality, this question is actually pretty bad. I don't think this is a realistic question at all. But um, we just have to follow it, right? And this is why it took forever because I was like, hey, realistically, will this ever happen? I was thinking in my brain, I was saying, no, it's a problem statement question, so treat it like a problem statement question is what I realized. There's a point over here, right? You might want to darken your so I get 3500 newtons per meter, and because we have done it, oh wait, it should be negative. Huh? It says clockwise here, so this is actually counterclockwise positive, so I must have messed up here. Yeah, that's wrong, I think. Did I make a mistake? Probably did. Over here, positive, right? Is it? Is it? What the hell did I do wrong? Let me read this question one more time. Um, point F, vertical upward force. Oh, the whole question is wrong. This question breaks summation of Fy because if you think about it, upward 1700 is wrong. It should really be to balance everything out downward. So this, uh, oh, I get it now. So even though this is going downwards, you have to think intuitively, it's all going downwards, therefore this must be negative. Oh, okay. Because to replace it, it must be negative. Now I don't like that because the wording is really weird. That is really weird wording. Okay, so this is wrong. And the answer is basically negative 11800. Because I was thinking, the moment must it must be true. So this is moment, this is the negative direction, so it's clockwise now, and we round up to D. They do these round up stuff that I hate, but you have to round up to the second digit or something, and if your second digit is rounded correctly, then it's correct. It's really weird. I don't really like it, but that's how they do it. The overhang beam shown to support by a roller square and a pin. The moment is removed and replaced. Oh, I get it now. The question actually should have started with fx equals equal, and we should have done like 400 times 2 plus negative minus 900, and that must equal 800. This equals 1700, but it must be negative. So you must intuitively figure out that this is negative by doing that. What a weird question. I don't really like that, but that's how it's done. Okay. The overhang beam shown is supported by a roller coaster and a pin. Actually, that's a pretty good question then. The moment is like that. Yeah, maybe it is. Maybe I'm the fool. The overhang beam shown in the is supporting by roller coaster, roller and a pin support. The moment is removed and replaced by a missing consisting of forces applied to A and C. Okay. Okay. What is the magnitude of the coupling, a couple of the couple that exactly replace the moment? That is okay. This is the wording is a little bit don't like, but the moment is removed and replaced with a couple forces applied at point A and C. Oh, these are these. Oh, I get it now. Okay. I don't really know why they would test you on this, although I don't know why. Um, maybe there is actually a real point to it, or just a real test. I don't know. Maybe in the real life world, I haven't. Maybe industry has something that I don't know about. Okay, so I'm the fool, and I should be more worried. So 100 newtons per meter in his C, right? So what is the magnitude of the couple that exactly replaces the moment that is removed? So again, these do not change, right? So we don't have to care about them, if I remember correctly. Yeah. But okay. And ah okay. I think I have wait. This is asking for the magnitude of the coupling, but you're giving me a moment back. That is not right. Is this the right question? Um, because it's clearly just C, right? Because you're asking for a moment. You need a moment. It must be replaced by the same moment. This is a retarded question. I don't understand what's going on. It's clearly C, but it is a nothing burger. I don't understand why that's even a question. Okay. What's the magnitude of force that constitutes the moment? Okay. What are you even saying? Are you trying to say you're trying to create a moment? I'm just gonna read this one more time. What is the magnitude that constitutes that moment? Well, a moment in here is equal to force time distance, right? And in reality, what happens is basically if you're doing a distance with a force, what you're doing, logically speaking, is you're making an equivalency over here, and this thing is moving as a d, right? But then you have a force over here, right? So what do you mean by that? I mean, I could just give out anything. The distance between the forces, right? Maybe it's saying the reaction force because of these two. Then you have to divide it by two, which I don't know if that's right. So let me just read this one more time. The moment is removed and replaced by it's still removed by a couple. Sorry. Couple consisting of a force applied at A and C. So I'm so sorry. I should have read that a little bit more carefully. What is the magnitude of the force that constitutes the moment? Well, the easiest way to actually look at this is just do this. By saying that this is this way, we can just say 2.5, right? Is equal to m, right? And we can just say the distance here, so it's 0.4 plus 0.2 plus 0.5. So then that is 0.9 plus 0.2, which is 1.1, right? 9 to, wait, am I wrong here? Oh, point 0.8, I'm sorry, it's point 0.8. So it's actually um plus 0.1 plus 0.1, so 0.2. So the distance equals 1.2 basically. With that said, we have this now. We have the moment. So we have F equal md basically. So with the calculator, you can figure out that the moment is clear 2.5 divided by 1.2, which is 2.08, which is 2.1, which is A. Okay, this was an awkward question. Okay, I can see a little bit of the value in this, but I still don't. I don't know what. Maybe it's in the FEM. I haven't done enough FEM in my life to actually figure out the use of it. It probably is in the FEM section, to be honest with you, the usefulness of this stuff. This body, which 4 centimeters, has 320 newtons force acting to the center of an unknown angle, and two 4e bound, okay, as shown. All these forces are removed and replaced with a single 320 force at point B, okay, parallel to the original 320 newton force. What is the angle? All right, that's interesting. So you're saying that this body shape with 4 centimeters, okay, has 320 newton force of acting through the center at an unknown angle and two 40-degree loads, okay, acting as a couple. So it's actually a moment if you think about it because it's already coupled. Um, because that's how it works, really. Um, held to the original 3-2 a single 324 is at point B. Okay, so you're replacing this moment, okay, and you're trying to get the angle here. So, I think I get it to the center. So this is not a static question again. This is a dynamic question. I don't understand what you're doing to me, but basically what you can do, there's two ways to look at this. If you do a moment diagram here, you find that 4e multiplied by 4 multiplied by 4e, right? Let me get my calculator. 4 multiplied by 4e is 160, multiplied by 2 is 320. So if you multiply by 2 equals 320. Equivalently, you could have done something called a movement algorithm movement and made it so that you do 8 multiplied by 40 equals 320. They're both equivalent. How they're equivalent is by looking at the 0 and moving it down. You move this down, you move this down because these are equivalencies. Basically what I found out is that 320 newtons per meter equals the moment on O, is the M moment around here on this whole body. And with that said, we're replacing that with a moment on B, right? So I don't understand what the point of the 320 is, although. What is the point of the 320 that's already shown? Like, what's the point? Is it just for decoration and just to troll you? It must be, because there's no reason for it to be there. So with that being said, what we can do is realize that I think it's the FR function equals M. And this is no longer a static question. This is a dynamic question. Why is it still in statics? I don't understand that. That's a doozy one. So we can just do F, which is 320 again. I don't understand why this is here. This I understand. FB equals 320. I think there's a mistake in the creation of this. I think someone messed up the making of this thing. So it's gonna be 300 and it's gonna be sine, right? And it's gonna be sine theta multiplied by 4 equals 320 again, right? Oh, also I should mention that this is going this way. So it shouldn't matter to do, yeah. So with that said, it is arc sine inverse to equal theta multiplied by 320 divided by 4 320 there. Yeah, that's a weird doozy question. I don't understand what the point of the extra information was, but it's just confusing to me. I mean, like, why would you waste your time doing that to me? I got 14 degrees, 14.457, so it's about C. I'm just gonna say C is correct and move on. It's not always going to be exact. They always round up errors or something here. I don't understand why that happens, but in the FE exam, it does that probably too. Rigid body subject to 3 concurrent coplanar forces. Okay. What's the minimum number of independent equations that are necessary to establish the equilibrium condition? So it is coplanar, right? Like coplanar, which means same position. I think it's no, wait, minimum is said, right? So minimum is coplanar, which has 3 concurrent coplane forces. Um, let's just look at this. There's a force this way, there's a force this way, and a force this way. I can play summation of fx, summation of fy, and make a couple equations. But by creating a moment, you can create something over here. A moment, by placing your moment at the point of entry, you can delete this essentially and create an equation of these two. So I could get a summation of moment. With that said, I can get rid of one. But it's two. Wait, actually, wait a second. I'm wrong. I'm sorry. We don't even have to use moments because it's looking for minimum independent necessary established equilibrium conditions, and equilibrium condition doesn't care about the moment equals 0. So it's just summation of fx and summation of fy. So either way is C. Okay. 3 congruent forces are acting as shown. If the force is in equilibrium and F2 is 11, what is the magnitude of F1? Okay, let's solve it. There's a few ways to actually solve this. Um, but I'm gonna go with the easiest way, which is summation equals 0. So we're gonna we have to figure out this, we have to figure out this. Okay. Let's think for a minute over here. If we put the y direction as here, then we know that 90 over here is in play. So what we have to say is 11 cosine of 140 minus 90, and this is the positive direction, and the negative for the other one. F1 cosine 135 minus 90 equals 0. With that said, we must play our cards correctly, where we say next is negative F1 cosine of 135 minus 90 equals negative 11 cosine 140 minus 90. And with that, we can say F1 equal minus 11 cosine. Are we looking for 1? Yeah. 140 minus 90 divided by cosine plus over here 135 minus 90. Is this correct? We'll see. 11 cosine 140 minus 90 parentheses. Cosine 135 minus 90 parentheses. I get 10, and that 10 is a b. I get 9.9999, but that's 10, right? We can all agree that is 10. So that is b. Next one, yeah, let me just clean it up a little bit. It's not, it wasn't that bad, but yeah. Which of the where can a couple be moved on a rigid body to have an equivalent effect? Along the line of action, in parallel plane, along the perpendicular bisect joined by two original, anywhere in the rigid body. It is anywhere in the rigid body. Uh, so if you have a movement like this, right? It's coupled, right? So 30 over 30. It implies that if you move any, because that's a moment now, you can move it anywhere in the box over here. So if this movement is over here, oh, you can move it over here. Oh, you can move it over here, as long as it has a rigid body connector. Sorry, that's a very powerful property that's used everywhere, and it should, yeah, it basically is what we use all the time. What of the following structure is statically determinate and stable with the load shown? Okay, let's see if I remember how to do this. So, oh God, this one's interesting. Okay, let's start with this one. This one has this. I should probably draw it how you're supposed to draw it for certain questions because it makes it cleaner. For this question, a lot of people like to draw it this way so you can visualize the force if you have the same color pen. It's not about it being right or wrong. It's about the colored pen because a lot of times we use color, right? Pen to denote. But if you don't have that colored pen like on the FE exam, you don't have that. It makes sense to draw it like this. So we have an F force over here. Okay, so we already know that this AY over here equals 0 because there's nothing here. And then we can use the summation of F x and I'm pretty sure f is known, right? F is known. We can use summation f to figure out a couple of equations, summation of m to figure out one of these and solve everything. So I is statically determinate. We can do the same thing over here, but here in another case, there's a normal force over here, but there's a moment over here and a plus or minus. So it's something like in this, in the reality of drawing. That drawing is kind of bad, but you can see that if you were to create a moment, there's another moment question over here. So that's one down. We have AX, which we use one of the X, and then AY. Here is a problem where we're not really, this is statically indeterminate, so we can't use that one. This over here, let's look over here. And what up, and then note, oh, let me take this one too. Okay, we have this, right? So how does this work is that we have to figure out zero joint members. So if this is a force over here, we know that by logical explanation, oh wait, this might not be a joint. This might not be possible for you to cut the joint because you have to look at it this way. This, and the last one is something, and I forget what the last one, but these two are the only cases where, and you have to be exception of this one. That basically has an exception, but yeah. To be told, I think this is statically indeterminate. This is way too much because this is already two questions over here. This is two questions. We don't know any of those two. That's four unknowns, and we only have three possible into these sections. This is impossible. Also, next we do this one. We have a normal force over here. We have a normal force over here. We have a normal force over here. Unknown. Three unknowns. That's not a deal breaker. But we have one force over here. Can we use a moment to couple these two? There's three questions. I don't think. No, no. I don't know. I don't. If I were to get that question, I don't think I could solve it. Which basically leaves A, and 12. No, no, no. I see what's happening. Um, this is determinate over here. That's why I'm wondering. But technically, this is a dynamic question. It's not stable statically, right? So it is A. It's three equations, but what happens is that it's going to move this way. So it's not a static question. It's a dynamic. I don't know why it's here. Again, so why is half of these questions not statics? It's a good question. I don't know. Three coplanar forces are in equilibrium on the surface of a steel plate as shown. Two other forces are known as 10-10. What is the angle of the third one? Okay, so this is another question about, well, usually the mass matters, but here the mass really doesn't matter. Over here, data. So what I would do in this case is just go straight to one of the ones. I think I'm gonna go with fx maybe equals 0. You could go y actually. It doesn't really matter. Should not matter. Anyways, with that said, same line of thinking. This is 45, right? So this bar is cosine. So 10 cosine 45 It's a positive, minus, and this one's over here, which is like this. So it's going to be also 10 cosine 30. And over here, it's going to be f cosine whatever theta is equals 0. And then it's going to just be cosine inverse. And then, actually, no, wait, what's going on? We don't know what f is. Oh, there's two unknowns. I was wrong. My apologies. What you have to do is summation of y. My brain didn't really register that you need summation of y for some reason, which is just 10 sine 45 as a negative direction, as you can see, minus 10 sine 30, and then you have plus f sine theta. Okay, this is not the way I think you're intended to solve it, because to be fair, I mean, you can, no, this is very much intended how to solve it. Man, this is gonna be a pain in the ass to solve. Um, First you have to solve this one by getting f over here, which is gonna be 1 divided by cosine theta, right? Which you could do that. You could do that. You have to do it that way. I'm not liking it. Is there an easier way to do this? I don't think so. Yeah, I don't think so. I genuinely think this is going to be the easiest way. So I'm just going to plug this into the calculator and negatize this. It's going to be negative 10 cosine theta plus 10, 45, sorry, 10 cosine 30. So it's going to be negative on negative 10 cosine 45 parentheses plus 10 cosine 30 parentheses. Enter. So that's something. I got 1 point that. So it's okay. I got f equal 1.5891869 divided by cosine theta. So that's one way to do it. And what you're going to do, you can plug it back into here, which is basically saying f, 1.5841869 divided by cosine theta, sine theta, equal 10 sine 45 plus 10 sine 30. And these are all the questions from textbooks, by the way. So what that means is that we can do 1.5841869 tan theta equal 10 sine 45 plus 10 sine 30. So we could just do arctan inverse theta equal theta is this 10 sine 45 plus 10 sine 30 divided by 1.5841869, which is what? I don't know. 10 sine 45 parentheses plus 10 sine 30 parentheses division of 1.5891886 just parentheses it is 82. I get theta equal 82.5. Oh, this is almost exact because 0.0000105 is what I get. So this is a really good question. I like it because it's exact almost. Okay. That's a good question. That's a lovely question. I must admit, I like that question because it's exact. I know that a lot of the FA question has not been exact, which is really troublesome, but who cares? A signal arm carries two traffic signals and a sign that shows below are rigidly attached to the arm. Each traffic light signals 0.2 in frontal area and 110 with weight of 60. Okay, all right. This is just a pain in the ass. The design wind pressure. What? The maximum moment that. Okay, all right. What's the maximum area of the sign? All right, that is an interesting question, I must admit. I think this is probably the hardest question in the. No, it's not. Definitely not. But it is definitely the most intriguing question. So, okay, okay. Go into it and use. Okay, so first of all, we know that the weight is over here like this. I don't know what this 9 meters is for. I mean, I don't think that's useful. The weight is given to us basically by doing this as what was it again? 210, 210. The sign weight was actually 60 meters per minute. So this is actually interesting. So unlike the other one, you have to multiply by the area over here to figure that out. Let's design wear pressure is 5715. I think that's interesting because you're going to have to do air pressure for everything, right? So because this has a chunk too. So what that means is that it's going to be a moment of wind. I don't know where you would even try to start the momentum. So that's interesting. Um, okay. Hmm. I think we're gonna have to choose. No. Um. We could. I mean, technically speaking, the only unknown is the sign, so we can choose the moment to be over here if we want. So the wind moment is basically okay. Yeah, let's do that. So the wind moment is area. What's the area? 0.2 parentheses by I don't know what was it again. 575. This is area times this weird force per meter square nonsense. Um, and then we can get the length of these two, which can be given by over here, which is 4.5. And then because there's two of them, I can just add another one, which is 4, 8.5. 8.5 looks like. Yes, I think. And then we can do plus whatever area we have, multiplied by what? Area multiplied by 60. No, not 60. 575 multiplied by 7.5. Okay, we have one of them. Summation of the m weight equals okay. Why are we doing moment? Can we not just do a force? No, I'm assuming not. I thought it was a 3D problem first, but that's not likely. All right, 2 110, and it probably is all a moment on the spinning top. So it should. I don't like this question. I hate this question actually. Yeah. So the maximum of this connection with the will withstand a wind of so it's 6,000 basically. I don't like this question because it's unclear if you're supposed to use the you know the moment on the what's the right word to say it? It's unclear if you're how 3D affects it. The question is not clear enough, in my opinion. Anyways, we can figure this one out and we can get the area. We can have a moment at 210 and multiply by 4.5. And then we can do this is gonna be a plus direction. So all of them is gonna be a plus direction actually. So what is 210? 210, 210, 210, 210. Another 210. So actually I did this wrong. My apologies. 210 multiplied by 4.5 plus 8.5. That's it. And then over here, we're going to have plus area, which is going to be, what was it called again? 60 this time, multiplied by 7.5 equal 40,000. All right. What an interesting question. We now have to solve this out. Area, okay. So 6,000 minus 0.2 multiplied by 575, parentheses 4.5 plus 8.5, parentheses equal that, divided by parentheses 475 multiplied by 75, I think, 7.5, parentheses. I get 1.04 for the area of this one. Area 1 estimate equals 1.04 meters square. All right, that is that one. The bottom one, I have 4,000. What's the maximum area of the sign? I think that just tells me the answer pretty much because the other one's bigger, so it is A. I don't need to check any more of these. You can, but that's the least one, so therefore it must be that one because ABCD choices tell you that. Okay. Two mesh spur gears are arranged such that neither gear is turning and both are in equilibrium. Excuse me, gear 1 has a radius of 4 centimeters, and gear 1 shaft carries a torsion moment of 65 from exterior motors. Gear 2 has a radius of 6. So for convenience, assume only one pair of teeth is contacting and transmitting efficiency 100%. What torque is transmitting by... Okay. Both as it is in equilibrium, right? So if I were to draw two of these like this, and this was the first gear with 4, the second gear with 2, and this has a torque of torsion of 65 newtons per meter. We can look at this and say moment equals force times distance. So it's 4 by the force over there is 4. So it is m divided by 4, right? Am I that close? I think I'm right. And then this over here, force over here, with second gear feels that whatever the moment is equal to F dot D, which the force is over there. So it's going to be moment equal M from the first motor divided by 4 multiplied by 6. So it is that, I think. Let me grab my calculator, and I hope I'm correct, but I might be wrong. So 65 divided by multiplied by 6 divided by some okay, that's a syntax error. I must have made a mistake here. 65 multiplied by 6 divided by 4 is 97.5. So it's B. B, yeah. Okay. Okay. We're almost done with the. All right. A hinge arc is composed of two pin curves, the members supported on two pins, as shown. Both members are rigid. A horizontal force of 100 newtons is applied at pin B. Okay, all coordinates are shown. What is the reaction for a moment at point A? Okay. 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 Hmm. Interesting. I would assume that the moment here is 0, 0 because think about it. This is a joint. It should not have any power over moment. So if it's any of these two, then it's terribly wrong. So with that said, we have to get something from here to get AX and AY. So we're going to do a moment analysis on C to make things easier for ourselves, assuming that we have the distance over here, which we do is 10. So we have the distance over here, which is 10. So we can do a moment of MC equals 0, dot, dot. What does that mean? We can do, oh no, we're doing the height of Y. That's 5, right? 5 multiplied by 10 is a positive moment. And then we're going to do minus. Wait, we don't know minus. What did we do with this one? We consider it positive, positive. This one is nothing there. We can get AY, although easily, easily in AY. We can get easily AY, right? Yeah, AY, and it's gonna be times by 10, and we chose negative direction. We chose a negative direction. My apologies on that. We chose a negative direction. So equal 0. AY equal. Wait, did I do something wrong? 5. Why is it 10? I meant 1,000. Sorry. Um, I was too excited. 5 multiplied by 1,000. It's gonna be negative, so negative again, so 10. That is 5,000 divided by 10, which is 500, which is this one. So it's B. We don't even have to check the other one. We don't check. And thank you. That